This Week in Radio Tech, episode 258, is brought to you by the Axia Fusion AOIP Mixing Console. Fusion is where design and technology become one. By the new Omnia 7 FM, HD, and streaming audio processor with Undo technology. And by Lava and the Crystal Clear Virtual Radio Console. Crystal Clear is the radio console with a multi-touch touchscreen interface. Hey, when is a disruptive technology something to embrace, and when is it just a passing fad? Easy to answer in hindsight, but how can broadcast engineers determine which new technologies to recommend and invest in? Bill Putney joins Chris Tobin and me, Kirk Harnack, for insight into disruptive technologies for radio broadcasters. Hey, welcome into This Week in Radio Tech. It's the show where we talk about radio technology, everything from, this thing, the microphone, to the light bulb at the top of the tower. I still need to get mine hooked up in here. I've seen somebody online take a 300 millimeter code beacon, that's the light that goes to the top of the tower, and put smaller bulbs in it and make it flash and all that. Bulbs that, don't just disrupt the whole place. So I got to do that. And put it back here, right behind me. Wouldn't that be cool? I got to do that. This is the show where we talk about all this kind of stuff. And today's subject, I think, is pretty fascinating. It's a little bit of a meta look at the technology that we put in place. This show is about disruptive technology and how we as engineers react to it. So I think it's going to be pretty fascinating and a little bit of a mental squeeze, a little mental look at how we conduct ourselves in the face of disruptive technology. As usual, my co-host is with us. It's Chris Tobin, the best-dressed engineer in radio, and he's here from his lair in Manhattan. Hi, Chris.
Well, hello, Kirk. How are you? I'm just reading my official gazette from the United States Patent Office and Trademark from 1988. And it's published weekly by the authority of Congress. At least it was at one time.
It was. So, is there any disruptive technology in '88 that we should be aware of?
Well, let's see. You got the 3M logo. There's a trademark.
Okay.
And then here's a disruptive one. You can see this if I do it right.
Dell.
Right there.
Is it Dell?
Dell Computer.
Oh my goodness.
Dell Computer, that was 1988 it was filed. Dell Computer Corporation. No claim is made to the exclusive right to the use of computer apart from the mark as shown. So the word Dell and computer, the way it's put together, is where the patent lies, and the trademark, that is.
Well, I'm glad they didn't, claim the word computer.
And then there's this one. I don't know if you can see this. You see the Chevrolet Corvette?
Chevrolet. Yeah.
Now, that says 1988, but the funny thing is, I'm looking at it, it says for ingots made of silver. First use in 1987.
Okay.
So that trademark has been embossed on silver ingots.
Maybe they weren't selling that many cars that year, and they need to come up with a new product. And silver ingots would, fit in the production line.
The marketing guys was working on something new.
Jeez.
But, just something I found going through some old file cabinets.
Well, Chris, I'm glad you're along because on the subject today of disruptive technology, you have been at the forefront of opinion on disruptive technology. A lot of it you embrace and agree with. Probably a little bit of it you say, nah, not going to happen. So I want to hear, obviously, your opinions as we move through the show on disruptive technology. And I want to bring in also our guest, Bill Putney. Hey, Bill, welcome in. Glad you're here.
Hello, everyone. Glad to be here.
Bill, your audio sucks all of a sudden. It was great during the pre-show, but it's terrible now. It sounds like the USB problem. You might want to unplug I don't know what you're using for a mic, but if you want to unplug it and plug it back in, that might help it. But it's all garbled. It's got that Cylon sound to it right now. So, but while you're doing that, Bill, I'm going to explain. Bill Putney and I were talking earlier today by phone. Bill called me and had a question. I tried to hook him up with the right answer. And I was saying, Bill, today on TWiRT, I want to talk about disruptive technology. And Bill has been, Chris and I sometimes get a little removed from day-to-day operations. Chris, less so than I. I've got some radio stations, but Chris is consulting all the time. Bill Putney is full-time engineer at his radio stations that he's working with in Port Townsend, Washington. And Bill's one of these guys that he doesn't have unlimited budget. He's kind of got to work with the technology that's affordable and usable at the time. And not that Chris or I have unlimited budget, but sometimes we get to try the cool stuff first because we work for companies or we pick our clients that need a solution that calls for cool stuff to see if it'll work or not. And so I wanted to bring Bill in on the show to see if what he had to add about kind of the real world in small town America about using disruptive technology. So we'll get to that in just a minute. Our show is brought to you in part by the folks at Axia. And of course, speaking of disruptive technology, the Axia Fusion audio over IP, AOIP console, and this is the newest offering from Axia. Notice on the website the new logo, LiveWire Plus. And I'll tell you just a second about that. LiveWire Plus is the term that the folks at Axia have chosen to give to the fact that LiveWire now encompasses a total of 3 different AOIP standards and Axia lets those work together as you need to. So there's the original LiveWire. That's the first AOIP technology or standard that allowed low latency, routable audio over IP. Well, along comes Ravenna a few years ago, and LiveWire and Ravenna made an agreement to work together. So LiveWire, that is Axia X nodes, work with Ravenna as well as with LiveWire. And then a number of manufacturers got together and other interested parties got together under the auspices of the Audio Engineering Society, AES, and with the X192 working group, they came up with a standard now known as AES 67. And it's a bona fide standard. Everybody can build, design, configure, write software to this standard of AES 67. And of course, LiveWire Plus encompasses the AES 67 standard as well. So LiveWire is the only technology, LiveWire Plus, the only technology that actually works with 3 different AOIP standards. They're similar in some ways and just a little bit different in other ways because different folks have different ideas of how to implement something. But now back to the Fusion console. The Fusion console is the result of having had the Axia Element console out there for 10 years, getting feedback from users, customers, engineers, people who actually put their hands on and use the consoles and on air shifts, and listening to that and finding out, okay, what could we do to make the Element series better? So it's not just a reskinning. There's some redesign, both in terms of hardware, in terms of infrastructure, how the console actually talks with the rest of the network, and in terms, of course, of software, features, and capabilities. And the Fusion console has just a number of improvements and feature additions to make it really the most powerful audio console for radio ever built. If you want to find out more about Fusion, I'll tell you the easiest way to do that. If you go to the website, to telosalliance.com, and then click on the broadcast consoles under the Axia logo, you're going to see some videos along with the Fusion console. And the videos are my colleague, Clark Novak. He's a former program director in California, works with Axia now, and he is great, does a fantastic job of explaining the new features in the Fusion console line. You can also see these videos by going to the Telos Alliance channel on YouTube. Either way, you'll find these videos, Introduction to Fusion, and then the 3 other videos about Fusion, and that will tell you what the console does that's the same and what it does that's different and better than previous consoles. And you'll see why Fusion is really the most capable, the most powerful audio console ever for radio. Check it out. You can go to the Axia website or Telos Alliance, or to YouTube and look for Telos Alliance and look for their channel. Subscribe to it and you'll get notified of the latest videos that are added to the website. A lot of them are training videos. I'll tell you, how this works and how that works and how to configure this feature or that feature. All right. Thanks to Axia and the Fusion AOIP console for sponsoring This Week in Radio Tech. All right. Disruptive technology. My goodness. There's been a lot of discussion, as there often is, on Facebook about disruptive technologies. One of the most recent subjects being having been brought up by audio watermarking and a product that my employer Telos has come out with called the Voltaire, and there's a lot of discussion about that, positive and negative discussion, and it brought to mind disruptive technology. Hey, when Henry Ford came up with the Model T assembled on an assembly line such that, more common folks could afford a motor vehicle, that was disruptive. That was certainly disruptive. It made people think, maybe I don't need to be limited by the speed of a horse. Maybe I can I can get something to carry my family around, go get the groceries, go to work, go to church, whatever it may be, and not have to do it behind a horse. So that may be an early example of a disruptive technology. Heck, the wheel was a disruptive technology. So were bows and arrows at one point. Of course, so was the pistol, the gun, the long gun and pistols, and then when they came out with bullets that were enshrouded in a cartridge, and you didn't have to load separate wadding and gunpowder and a bullet all separately. That was an interesting new disruptive technology. And as we get into broadcasting, a number of new technologies came along that were somewhat disruptive. I guess I want to look at stuff that's happened in the more recent past, maybe in the last 10 or 15 years or so, that's been disruptive technology. And maybe Chris and Bill, maybe we can name off a few. I'd like to start by naming the all-digital FM exciter. With a numerically controlled oscillator. Instead of an analog exciter, have a numerical one. You could also name, of course, audio over IP, whether it's in studio use or whether it's over distance, over public internet. Even audio compression technology like MPEG Layer 2, MPEG Layer 3, and now we have AAC. These are disruptive technologies, not without their occasional faults, but also not something that was adopted immediately. There have been naysayers. I remember reading articles back in the mid-90s about how MP3 is terrible. It doesn't record all the notes. There's even an ad I saw, or a public service. Somebody wrote an article that showed a keyboard with keys missing from the keyboard and saying, "This is what MP3 does to your songs." Bit of a misnomer. But Chris Tobin, maybe you'd like to pick up on the conversation at this point with some examples of disruptive technology.
Well, I'm going to go back a ways, way back machine. Real Audio and Windows Media Player.
Oh.
Now, the reason I say this is because they were disruptive at a time when it was common practice to possibly use cassettes to record for sports or news actualities, or if you're doing an event somewhere and you needed to get quality audio, you had that type of technology. I early on back in 1998, now that I think of it, oh my, probably a little early. Working for a small network, we had been challenged to try and get audio back from the field that was good quality, but couldn't wait for it to be done in real time, say over a phone line connection using a phone line extenders like the Gentners or the Convex boxes back in the day. So I experimented with some product called Real Audio. We're like, wow, we're doing some stuff with this thing called the internet. And I wonder, what if we recorded using this and sent the file back over the internet on a dial-up, as we had, or these slow speed connections, and that way you'd preserve the quality but get it in a quicker than real time. Well, it worked out, and all of a sudden it became a hot item, and we totally screwed up everything. Fast forward to today, and then you have now it's common practice to send digital files around. But I would say Real Audio, Windows Media, that sort of got people thinking differently, and then Skype came along and made people think even more differently. So,
hey, I understand Bill Putney's back with us. We're going to bring him in just a minute. But Chris, what was interesting about Real Audio at the time is that was a tech that was designed to actually give you audio at dial-up speeds. It could go down that low, and prior to that we had MPEG Layer 2. That's been we had G722, but that was 64 kilobits, and by the time you packetize it, you're looking at 100 kilobits, which it wouldn't fit over dial-up. We had MP2, which was really not good, below 96 kilobits per second or so, for mono audio, maybe 64 kilobits on a bad day. But much higher speeds, appropriate for file and hard drive at higher speeds like 192, appropriate for satellite distribution at 192 or 128 if you had to. 256 was a bit more ideal there. But then along comes, as you mentioned, Real Audio, which sounded pretty bad, but was better than telephone.
Right.
and could operate down in these low bit rates of what, a 20, 22, 24, 28 kilobits per second. Was that a good
Yeah.
low
Yeah.
end?
Now, as a result of Real Audio introducing this ability to bring, as we by our standards would say, it's poor quality audio, that's when the POTS codec started to emerge because
Oh
people started
yeah.
to accept the fact that, hey, if you could squeeze what we think is tolerable audio that's better than, say, phone quality, let's do it. And think of the disruption that Real Media and all these guys did, and all of a sudden POTS codecs come along, and now you're able to put our voice and somewhat music across a dial-up line and do real-time digitized audio.
Yeah, yeah, and interesting. Now let's Bill. Let's hear from examples from you. We haven't moved into the part of the conversation yet, Bill, where we're really talking about engineers' reaction to disruptive technology. So, but let's get your ideas of a couple of disruptive technologies, Bill.
Well, I think, a lot of the things that we've been talking about have been, especially these audio codecs and video codecs and that kind of thing, are the result of people taking digital signal processing and that mathematics and applying it to entertainment, if you will, sorts of regimes. The work that Steve Church and Skip Peasy did and AOIP built on a lot of that work that, if you go way back to Shannon, and you go way back to all those guys back at the Bell Labs that were working on how to get the most intelligence over the smallest circuit, and we come forward, and the cellular telephone and the digital cellular telephone and all those things were disruptive of the. I mean, look at what cellular has done to two-way radio. Two-way radio is really a boutique kind of a technology now, because cellular has become such a monster in the market. You look at, I mean, going way back, you look at what networks did to radio, being able to connect a lot of stations, not even the great big huge major market stations, but because of these technologies, being able to connect even small market stations into big networks has really changed the face of broadcasting. I mean, you can see the small, if you will, disruptive technologies, or the contained disruptive technologies on a station by station basis, but you also see these huge global disruptive technologies that really mark broadcasting and the things that we're doing today, even in a small market like we serve here in Port Townsend. All those big market technologies, those global technologies, play into what we do here, and it makes it possible for a small full service station like we are, or a low power station, to really have a big broadcast presence.
I was just riffing some ideas off what you were saying there. You mentioned cellular, Bill. Oh my goodness, has that just not supplanted so many things? Pagers, the whole paging industry. I mean, who has pagers anymore? Yeah, I know a couple people still do. Remember when we had paging over RDS? Well, Q Paging was the big company there for interstate truckers especially. Then we had because Q Paging solved the problem of roaming with paging. This was back in the 80s and 90s, before there was cellular or cellular roaming. Conveniently, if you were a trucker and you wanted to cross country and know when somebody wanted you, Q Paging was about the only way to go.
Well, and all those SCA services. I don't know whether there's much radio text anymore. All those background music services. All that, stock quotes over your pager, over the broadcast band, all those really interesting little applications for SCA that used to make small stations money are all kind of missing now.
Chris,
It's been very disruptive.
Are there any reading for the blind services that you're still aware of on FM?
It's funny you should say that, because I was talking to someone a couple of weeks ago that was mentioning that there was a service available on a subcarrier somewhere for reading for the blind. I'm not sure where, though. I believe they're still around. There's still
I can imagine some FM stations keeping that because of the legacy and because perhaps of the difficulty in reaching blind folks who need to update the technology, and somebody's got to pay for it, and a lot of blind folks are probably on the poorer end of the economic spectrum. And so, it's takes longer to get people updated with newer technology. But for a couple of decades or more, reading for the blind over FM subcarriers was a popular use. You mentioned two-way radio has been supplanted along with pagers. So we got, of course, the internet has changed almost everything, and that includes voice over IP television. One of the things that really changed it has been digital storage. Because we used to have tapes, right? And I haven't had a tape machine in a radio station now in about 12 years. So just no need for tape. It's digital storage, networking even within a facility. That ability to have computers talk to each other changed a lot. Computers and other appliances, especially now coming on, we get more appliances that include networking with them, whether it's got live wire or audio over IP that's live, or whether it's just for machine control or some kind of setup. Networking has changed a whole lot of things. So and another disruptive technology that actually started the conversation is how we measure audience in our business, in our industry. When I was a kid, I remember the neighbors had a little box along with their TV set. And I have no idea what the tech was, but I just know that the box knew what channel that they were tuned to. I don't remember if it was cable or over the air. Are you guys familiar with any of the older technology to measure television audience?
I thought some of those boxes actually were essentially TV tuners, weren't they? And so the TV listened on channel 3, and then you actually tuned the box, and so the box knew what channel you were listening to. But of course, before that, there was all the dialogue, book by the side of the easy chair that you could write down what you were watching, kind of thing.
Diaries.
But of course,
diaries. Yeah.
Right.
Chris, what did you have in New York City? Were you aware of how they did ratings then?
I never knew of anyone that had the ratings box services, but I do recall hearing about Manhattan Cable Television at the time. It was a box they'd install, and then just, as Bill says, you just tune it, and whatever you tune to, they would record and monitor, and that's how it worked. And then the diary services, I do recall people always talking about that. Yeah. And I wish I knew more about how television measurement works, because I know now they can do ppm to see what you're exposed to, with the television audio. There's a little bit of a disconnect in my mind. It seems ideal for cable companies and rating services to work together, because the cable company has got to know what I'm tuned to, even with a modern, DOCSIS type of cable system. But what they don't know is if my television is turned on or off. Because right now I've got 3 cable boxes in the house. They're all turned on. We don't tend to turn those off, especially because of the lengthy amount of time it takes for them to receive their program schedule information. So they stay on all the time. But right now the 3 televisions in our house are all turned off. So the cable boxes may all be tuned to the same channel for all I know, but the TVs are all off. So there's no measurement available there. Does HDMI know if the other end is turned off or not? I guess it could. Does it know if the source is selected?
HDMI is bidirectional. HDMI is bidirectional, so in theory, of course, it could know that there was a monitor, and it knows some characteristics about the monitor. So if the monitor is turned off, that data is missing. You could conceive of an engineering solution for a box that would be connected by just your standard composite cable would be to just have a microphone with a level detector in it, and if the audio coming in the microphone matches the audio going out on the audio carrier of the modulator for the audio output jacks of the box, then the receiver's turned on. I don't know that any of them do that kind of thing, but there's probably some clever ways to find out whether the receiver's turned on.
Yeah.
But of course, you know that it's fairly recent, until the internet became a very popular thing, that the reverse channels in cable systems were even equipped. So, I mean, having that ability to upstream information, I guess in a sense could be disruptive, in that it opened so many possible avenues for exploitation.
So with all this set up in our discussion, why don't we move right into the subject that I want to get to, and that is, as engineers and users of technology and users and acceptors or not of disruptive technology, I'm really interested in talking about how we react to new technologies. And having been in sales and marketing and doing seminars for the folks at Telos and Omnia, and then along comes Axia, and then 25/7 and Linear Acoustic. I've got a fair amount of experience in explaining a new product and a new technology to audiences, typically SBE meetings or NS workshops or NAB presentations, or just meeting with people one-on-one and talking about it, and then judging that reaction that you get from them. It's really, really amazing, the difference in reaction that you get from people. And then that makes me think about my own reaction. Am I the kind of guy that whenever new tech comes along, I just say, yeah, let me at it? Or may I look askance? Because, I know there's things that come across my horizon that I, look at with doubt and a non-acceptance right away, because I think I know all about it. And so what I'd like to just kind of set up the conversation by saying what I see as reaction from folks. And I'm guilty too, but I'm probably guilty in other areas besides tech. Tech, I tend to be very accepting. Probably a lot of us are, but there are some engineers who are not accepting of new tech. And we look at a new technology, and I guess we could use audio over IP because 10, 11 years ago, when I was going around the country introducing people to the idea of putting all their station audio on a computer network, that was pretty scary for some people. And why was that scary? Well, interestingly, some younger engineers were enthusiastic, and some older engineers were not enthusiastic. And I was on the cusp. I was between these two areas. I knew in theory that this could work pretty well. And of course, working for the folks at Axia, I could see. I demonstrated to myself over and over and over again that this worked really well if certain things were in place and certain obstacles were not in place. But if you're the type of engineer and you grew up or you came up in a station that added networks, and let's say a typical problem was a salesperson hit the print button or hit the print screen button or clicked print on their computer and nothing happened at the printer, you may be inclined to think networks are nothing but trouble and they don't work right and stuff doesn't talk to each other right. And so I can see where engineers, including myself to some degree, would have the opinion before they'd ever accept AOIP that how am I possibly going to put AOIP live audio, my live radio station audio, how am I going to take that off of a cable that I know about, let's say an analog or an AES point-to-point cable, and put my product onto a computer network that the sales staff can't even get something to print reliably and repeatedly? How the heck are you expecting me to put this on a computer network? I'm going to be off the air a lot if I do that, you fool. that was a lot of folks' first reaction, and understandably so. So you back up and look at that picture, and you realize that people form opinions before they even try something based upon their past experience. And it would take a lot of explaining and showing folks, well, an AOIP network, we're going to run this a little bit differently than you may run your business computer network. We're not going to have printers on this network. We're going to use professional switches. We're not going to use something that came from Walmart or something that comes in a plastic case. We're going to use real by golly hardware. And I find that engineers that I would talk to that would have doubts about the tech, they really had never been exposed to the right way to do the tech. All right, I've said enough about that. Maybe, Chris, you want to comment on that, about how people react to something that seems iffy because of their past experience with what they think is the same thing and really may not be. Oh, yes, Chris, talking to you.
Yes, unmute your mic.
Sorry. No, I unmuted the mic. Sorry about that. I took a phone call. I shouldn't have done that.
Oh, I'm sorry. So, well, I'll tell you what, let's head over to Bill. Bill, because you've experienced this too, and I'm sure you've got some thoughts about this notion of accepting a tech that your first reaction is, What do you think?
I'm a bad example, I guess. I'm an old guy. I was around, when the FM stereo wars were going on. So I've been around a while, and I do get, when something new comes down the pipe, I do get kind of backed off a little bit. But it really, for me, is I'm always curious about things, and so I want to read the white paper. I think it's unfortunate that these days that people are so, that manufacturers are so concerned about their intellectual property being hijacked, that the old manuals that you used to get that said this is the theory of operation of something really don't exist anymore. So, finding out how something really works under the covers is hard to do. I have a lot of personal experience with technology, and most engineers have a lot of personal experience with technology, and they understand a lot of fundamental things. Taking those fundamentals and applying them to this new technology that is being presented is a hard thing to do if all that stuff is hidden under the covers. So yeah, I mean, I feel torn. I think probably a lot of engineers do, that they don't want to threaten the quality and the reliability and the expectation of listeners and viewers that the service is going to be there. And if they do something that threatens that reliability, we as engineers really have to step up and take responsibility for that. But on the other hand, some of these technologies, AOIP is an excellent example, make the systems we use so much more flexible, and the capability to bring more and different kinds of entertainment content to viewers and listeners than we could have done with 12AX7 based audio consoles and twisted shielded pair. So you have to look at not only what the threat is to your current way of doing business, but what the opportunity is to really make things shine and make life easier. I don't think that we here at KPTZ in Port Townsend, we built our radio station right on the leading edge of audio over IP, maybe jumped in half a year too early, but I think in retrospect it was the right move for us, because it made building a small station on a small budget possible with a small crew. There's just no way of that we could have done what we did in the time we had and the money we had using conventional technology. It just wouldn't have been as rich an environment for the creative people to work in if we hadn't done it the way we did it.
Gotcha. Yeah. Chris Tobin, you have some comments now about engineers' acceptance and pushback on new tech.
Yeah. Oh, yeah. Yeah. I mean, I worked at a facility. I got pushed back big time trying to implement audio over IP. And as Bill pointed out, the technology, the new stuff, you tend to be a little hesitant, of course, and you hope for the white papers, you hope for some kind of information to learn more about it. And I've had discussions and sometimes heated arguments with the Elmers, if you will, the elders in the industry, about some of the new stuff. And I would say to them, I said, well, you know what? When I was starting out, I remember being browbeaten on many occasions, building a transmitter facility and making sure that I had an RF switch that had interlocks, had a dummy load connection, so that no matter which transmitter was on or off, it was terminated properly either into an antenna or into a dummy load. And if it was into the dummy load had an interlock that made sure that backup transmitter couldn't go on unless the fan was turned on the dummy load for cooling. So that type of thinking and design, I'll call it, form and factor, is what needs to be looked at for some of the burgeoning technologies. Now, my example, my experience with Axia back in the early days, I'll call it that, early days, was the same thing. I sat down, read the papers, talked to people, I figured out what it did, and I said, okay, if we're going to do it this way, how is it going to be implemented? How do I make it as robust as, say, as Bill pointed out, the twisted pair wire that we're accustomed to, or a 12AX7 tube console? How do I mimic that form factor but take advantage of the new roadmap? I can create a roadway. And it worked. It took some time. I mean, I had to do a lot of reading, a lot of research, and it was interesting planning, but it worked. And once we did it, it opened up all these creative juices of the people that use the technology, not the engineering, but the editorial folks. And all of a sudden, it became this wow, and people were a little more willing to accept newer things. But I think as engineers, we have to really apply the same form and duty that we've done with the older stuff, whether it's building a transmitter facility, erecting a tower, placing an antenna on it, building a directional array and knowing the phaser needs to be done a certain way. Same thing should be done when you take that Ethernet switch and that AOIP device and say, okay, how do I make these two talk and be as robust as I'm accustomed to in this business? No reason why you can't do it. And I think nowadays, whether new or old or young or old, you need to say, okay, what do we do? How do we do it? And find the way. And if the company, the manufacturer, doesn't want to give you the information, you know what? Power of the purse. You tell me, look, pal, nice stuff you got there, but unless you're going to work with me, I'm moving on.
It might be, it might be interesting for us to think about what technologies have come along available to broadcasters that turned out to be a flop. That, hey, I implemented this tech or that tech, and one of them was that what was that noise reduction system available for FM that just didn't go anywhere? Yeah, FMX. And we'll tell you what. Let's talk about that in just a minute. I want to squeeze in one of our sponsors here, and I want to tell you about one of our sponsors being Omnia, and a new product that they have that they brought out at the NAB show called the Omnia 7. We've been talking about the Omnia 7 for a few weeks now, and the Omnia 7 is ideal for stations like mine, like the ones that I have, where, look, we're in a small town. We just cannot afford a $15,000 processor, no matter how good it is. Well, the Omnia 7 is a processor that the base price the list price is about $6,000. And the street price is a little bit less than that. Go to your favorite dealer, make your best deal. But it doesn't come with every option. For example, if you already have an RDS encoder, no problem. Just hose it into to your exciter or into the processor and you got RDS. But if you don't have an RDS encoder and you want one, well, you just pay the folks at Omnia a little upgrade price on a license and you turn on built-in RDS encoding. So you can get that display, and not just static either. Dynamic RDS encoding is available in the Omnia 7. If you want a processor for FM, the Omnia 7 will do it. If you want to choose for it to do your HD processing or stream processing and do stream encoding, it'll do that too. But it won't do FM and HD at the same time unless you pay for a license to do that. You can upgrade, so you can choose one or the other, or you can do both if you pay a little extra money. I'm going to grab my camera right off my monitor here and bring it forward and show you the Omnia 7. I'm sorry if I'm not holding it very still. There's an Omnia 7. I've only got this for a few more days, and I've got to send it off to some other folks in the company. But there's the beautiful front panel of an Omnia 7. Now, why does the Omnia 7 cost so much less than, say, an Omnia 9 or an Omnia 11? Well, one reason is this is not a touchscreen. It's beautiful. It's a great display, but it's not a touchscreen. You access all the controls, all the menus with this knob right here. And so you can it take you a few minutes to start finding your way around the Omnia 7, and you can also go into and totally remote control the Omnia 7 with the NF remote software. It comes with every Omnia 7. It's Windows software that it's an executable you run. You connect to the Omnia 7 across the network, and you can do that locally. Usually I control it right here in my office, even though my computer and the Omnia 7 are about 4.5 feet from each other. But you can also, of course, make it work remotely. And NF remote, it's really cool software that Leif Clayson has designed. If you're an engineer that takes care of a lot of radio stations, you can set up NF Remote to have all of those as presets, as quick connects. So no matter where you are, if that Omnia 7 or Omnia 9 is available on to you across your network, then you can access it. The Omnia 7 has a few cool features, like it's got the built-in stereo embedder. This gives you 1 dB more loudness at absolutely no extra cost in processing. It does this by embedding the stereo pilot instead of adding it on top of everything. It's not a pilot clipper. I don't know what the magic is that makes it work, but Frank Foti has a new video out on the Omnia YouTube channel that begins to explain it. You can also, if you want to, you can cut off the upper sideband and do the single sideband stereo if you feel that will help reduce multipath in your particular market area. Lots of displays are available. You can set them. This is all customizable, both on the NF remote and on the front panel here of the Omnia. To get to the menus, here you go. I just pushed the button, and now you can scroll up and down through the menus and get to the various menu things and do all that. Just amazing the amount of stuff that's available there. It's a lot like the Omnia 9. Let me put my camera back there. Sorry about all that jostling. It's a lot like the Omnia 9, but it just doesn't include everything. It still has powerful Omnia 9 style processing. I think the Omnia 9 will do up to 7 bands of processing. The Omnia 7 will do up to 5 bands of processing. A lot of similarities, a few differences. And if an Omnia 9 or an Omnia 11, if that's just a little bit out of your budget like it is for me, you really owe it to yourself to check out the Omnia 7. Go to the Omnia website. Just go to telosalliance.com, click on Omnia audio processors, and check out the Omnia 7. It's $6,000 list price. Just amazing, the value. Oh, it does have 2 power supplies. It's got redundant power supplies in there, so it's got some big boy features and not a big boy price. Thanks, Omnia, for sponsoring This Week in Radio Tech. Okay, what did I say we were going to talk about just before we broke for the commercial?
FMX.
Oh, yeah. Technologies that you didn't adopt and you're kind of glad you didn't. So FMX comes to mind. I remember when it came out, I was thinking, oh, this could be cool. But it would have required, receivers having this tech involved, and that never really happened. AM stereo may be another tech that, hey, I was on board with. We installed it at several stations and saw AM stereo in cars for years afterwards, and nobody ever knew it was there.
Quadraphonic.
Quadraphonic. Yep. Oh my goodness. How do we know the difference between a tech that we need to move to and a tech that, let's see what happens. Probably a flash in the pan. Any ideas about that? Bill, you want to take that question?
I think that engineers have to look at the fundamentals and say, what will this do to to my service.
Fundamentals.
Station owners,
yeah. Is this
station
fundamentally
owners
something
at,
that we need to go with? Yeah. Go ahead.
right.
Sorry.
Station owners look at, can I sell this to an advertiser, or will a nonprofit station subscribers want this? There's a lot of things that you can say, just kind of fill in around the edges that maybe people won't notice or won't hear, that are hard to sell. It might be a very good idea. It might be the Betamax versus the VHS, but if you can't make a compelling case for it for yourself to want to have that technology, you have to wonder, how easy is it going to make to be able to make a case for that for a listener or a subscriber or a sponsor to pick up that tab. Ultimately, the sponsors end up paying for the tech. We're the happy recipients of a new toy, but the sales guy has to make his numbers, to make the station's numbers, to make, and it all comes downhill. One of the things that we were, just to go back for a minute to adoption on the part of engineers, it's really hard, I think, now, especially when so many engineers are not engineering for one station. They're engineering for a group, or maybe they're consulting engineers and they have a lot of stations that they work with in a geographical area. One of the sort of disruptive technology that's made that possible, likely a remote screen on the Omnia 7 or any of these kind of remote capabilities, to be able to get transmitter readings over the network, to be able to go in and tweak an equalizer or a processor without having to walk up in front of the thing and twist a knob. That's been disruptive, but it's hard for an engineer to make the time in their schedule, to justify the time in their schedule to explore a new technology. And I would never feel very comfortable about just closing my eyes and jumping on a technology. I'd really like to have one to touch, or go talk to somebody who's done one. The Steve Church Skip Peasy book on AOAP, I probably read twice before I decided that, we could take a flyer on this. And I had a lot of background in digital technologies, so I was probably an easier sell than some.
And just because you're an easy sell, or the tech is available, or Steve Church or Skip Peasy says it's good, you got to ask yourself, is that good enough to invest your station's money in that kind of technology? One example might be, years ago, Telos came out with an idea. They thought that maybe it would be worthwhile to have a box that could take one ISDN codec call and distribute it to a number of other ISDN boxes. So make a little mini network of ISDN. And Telos put a lot of money into that, and I don't know if they ever sold one or not. They may have sold one. They may have sold two. I think they sold the idea off to somebody else and washed their hands of it. That was before I came on board. But for some reason, it never took off. It wasn't interesting to anybody.
There's an IP version of that too, multicast, which is a great technology. It's essentially broadcast over the internet, but the ISPs never implemented it. So if you're, on a campus, or if you're, in a small town that has their own community infrastructure, it's a great way to use a little bit of bandwidth to build a broadcast environment, essentially. Mm-hmm. But it just never got very well implemented and didn't take off. And I, talking about about, is this product the right thing for me? Not only does an engineer have to understand what the technology is behind it, but it's incumbent on the engineer to understand a little bit about how that technology is being implemented by the people that are making that product. Is that company, are the engineers that work at that company doing a diligent job of implementing the technology? So there's certain market leaders that shine, and you say, well, yeah, I can kind of take it to the bank that these guys have done it right. They know how to do it. And there are guys that you say, nah, I just assume I know, they're using the same tech, but in the past they've not been very rigorous about their implementations. So I mean, there's the value judgment there, even understanding the tech, understanding the likelihood of a good implementation from any particular vendor. So there's a lot of things that roll into that, and a station manager that says, hey, go get me some new tech. It's the engineer that has to actually, step up to the bar and say, well, I've got 3 products here that do, as far as the spec sheets say exactly the same thing, which one is going to be successful in our environment.
Yeah. That's a question we often apply to, good old traditional products like FM antennas. You buy a 4-bay antenna, they all have very similar gains, gain figures. You have reputations, you have biases there. Chris Tobin, what do you think about the notion of how to avoid buying a pig in a poke when it comes to considering disruptive technology?
Well, doing your research, understanding it. I mean, part of the reason why we see a lot of things not happening the way we'd like anymore is in part the phrase, no one ever was fired for buying IBM. And I say that because I was one of, it used to be true, yes. Well, Lenovo, how's that? Or Motorola Mobility. FMX, I was one of 3 stations that did the experiments and all the beta testing and development work, and spent many a night driving a van throughout the marketplace testing it. And it actually had promise and actually would work. However, it did require a little tweaking. Unfortunately, the industry didn't get behind it because nobody was willing to learn it. And that was at a time back in 1988, 86, when the industry was shifting from a let's make money because that's what we're about to how do we sort of do financial engineering and get away with what little we can, and deregulation started. So, FMX, AM stereo is another example, 2 competing systems. But if you just looked at the technology and said, okay, which one made better sense? Well, the independent sideband one was more robust, but the marketing of the quadrature type apparently worked better because they had the ears of those who were willing to sit and listen and sort of got bullied. So things like that happen. And I think nowadays we don't have companies or business, business schools are not turning out businessmen or business people. They're turning out people that can just make numbers work and move on to the next, fee-driven success story. So, disruptive technologies are left to people like Cisco, maybe Cisco, HP, or Apple, or Google. And now all of a sudden, we're leading from behind because we can't do anything about it. As Bill pointed out, do you have the resources to do it, to learn it, to say yay or nay? Now you just sort of have to go with it. And then, Telos is a perfect example of a company that did the opposite, that bucks the system. Amazon's another one, where you guys look at something and go, no, you know what? We're going to go with this. This is how it's going to be. And we're going to figure out a way to make it apply. And you know what? So you make a few pigs along the way. If you really want to understand what it means to fail to succeed, which is the proper way to look at it, read a book about the Idea Factory. That would be the story of Bell Labs. Bill mentioned earlier a person by the name of Shannon's Law. Shannon's Law, actually, he was a scientist at Bell Labs. Back in the early 50s, or was it 40s, he developed the formula that determined what digital systems do today as far as noise and bandwidth is concerned. This was before digital was actually a household name, but Bell Labs had already developed all the protocols that we use today. But they failed a lot, and they just kept at it and realized there's more to go. And they had a culture that thought that way. Broadcasting had that same culture for a long time. It's now gone. So now you have people coming up through the ranks that just don't have the drive to learn it new. They just accept what's there and go, okay, how do I apply what's already been built and put it into my little widget of a workflow and see if I can now adapt to this method rather than really excel at what we do. And that's where things have gone.
So the most recent topic that has come up at NAB, there was a lot of buzz, and this is not just a company claiming there's a lot of buzz. I mean, it's there's been articles about it seemingly every 2 or 3 days in the trade press, and that has to do with audio watermarking. And is the methodology improvable? Can we make it better? Can we make sure that stations get credit for a higher percentage of people who are actually exposed to that? And so this is a topical show. The subject of all this has been a product that the 25/7 division of Telos came out with called the Voltaire. And it's interesting. A number of people have embraced the tech very quickly. Literally about 300 radio stations have already put their money where their mouth is and bought this. It's a product that goes in line in PPM markets where Nielsen measures audience by watermarking the audio with a signature that is unique to each radio station, and then people wear pagers to pick up to measure what they're exposed to. And there are some problems with the tech. It's not because the tech is poorly designed, but just because there's only so much you can do to hide a signal where people can't hear it, and yet a device can. And so I never knew that anything could be done to improve this. But I guess the short version that I want to get to, the short version of what I want to say is that after talking with and dealing with the people who are behind this Voltaire technology, and the chief one being Dr. Barry Blesser, he's an MIT PhD, and he's an unassuming guy. He loves the tech. He loves to make tech better. And you meet Dr. Blesser, you talk to him for a while, and this guy is the farthest thing in the world from a snake oil salesman. And yet it just seems like some folks in the industry are treating this new tech as if it's snake oil. As if, I can do that with a reversed diode making some pink noise, or I can do that just by boosting 1 to 3 kilohertz of audio and thereby boosting the watermarking tones. And my goodness, it's really a lot more complicated than that. And of course, the people who designed the Voltaire, they're not disclosing exactly what they're doing inside, although Dr. Blesser's NAB presentation points out what the challenges are, and from that one might deduce, if one expands one's thinking, what might be going on inside the Voltaire. I can't say because I actually don't know much about it either, except what Dr. Blesser says the challenges are. So I guess I've been a bit taken aback at the negativity about the technology, both from a technology point of view and from a business point of view. I get it if you're a small station, you're in a big market, and the last thing you want to do is spend another thousands of dollars to help assure that you're getting credit for the listeners that are exposed to your signal. But in this world now, we have apparently 2 sets of ears out there. We have the human ears of the listeners, and now we have the PPM ears. And we can actually, now that we understand a lot about how the PPM system works, we can process the audio, process the PPM so that it is more effective and reaches more people. So I've yapped on for several minutes here. Chris, do you have a comment about this kind of technology and people's acceptance or extreme pushback on this kind of technology?
Well, at NAB, I did bump into a few folks regarding the Voltaire's capabilities and what it talks about, and Dr. Blesser's paper and his presentation I thought was excellent, and it does tell a lot. And if you really are a techie person and really understand or want to know what you do, his presentation and paper pretty much doesn't tell you the secret sauce of Voltaire, but it does tell you what it needs to do to make things better so you can understand it. As far as the pushback and the way some of the rhetoric I heard from a couple of folks that was really nasty, I liken it to Salem, Massachusetts. You know, back in the day, burning witches because of the fact that if you toss somebody in a lake and they sunk and didn't come back up, that they were a witch. Yeah. Voltaire is sort of telling people, by the way, when PPM first came out, and I remember this in the early days, and I know many friends of mine who are now retired from the broadcast engineering, and we all said that we don't believe this technology is right. There's something amiss. And we voiced our opinions to many of our corporate brethren, and well, shot down very quickly because depending on who they talked to, dictated what was really going on. That was 6, 7, 8 years ago. And here we are today with a device that now proves the point that there is something to be considered and needs to be looked at. I don't think Voltaire should be taking a hit. I think what should be happening is the Nielsen / Arbitron / Birch / whatever they are these days should be taken to task and say, hey guys, there's a technology that says that there may be a flawed response to this measurement tool, and we need to talk, because the other disruptive technologies like web-based analytics seem to be more accurate and give me the information I need. However, the over-the-air analytics that you claim you can create could possibly be flawed. Why aren't people going after the ones who are the source? Because somebody's able to prove or demonstrate that maybe there is there's a possible crack in the armor of this system. That's where I see where things should be talked about. I don't think Voltaire should be beaten up. If anything, somebody else should come out with another device similar to Voltaire based on similar thinking and say, hey, you're right, there is a problem, or maybe not, or there's a way to improve on it. That's just my opinion.
Yeah. Well, shoot. One of the key things that Dr. Blesser said in his presentation, I thought was, folks, I'm not saying that there's something wrong with PPM technology. If you asked me to design this, and he could have, I couldn't make it any better than it is. There's the laws of physics we're dealing with here. Although Blesser's presentation didn't say this, the watermarking tones are not below 1 kilohertz because of certain reasons in analysis. It's too difficult to do that. It takes too long. And then you can't have them too high in frequency. There's things that get lost there. So the frequency range of 1 to 3 kilohertz is where the masked tones are put in. And, if some program material is lacking in material in 1 to 3 kilohertz, or if it's very staccato material with only click type sounds, or what ends up being clicks, if the material's not long enough, like some human voices doesn't have a lot in there, it's not going to code well. There's no opportunities for coding, and that's not the fault of Nielsen. That's the way the world is. So if we can figure out a way to just improve that on a statistically significant basis, and then demonstrate by showing graphically to the engineer, to the user, to the station owner, look, we improved this much. It still isn't perfect, or maybe it is, but it still isn't perfect, but it's a lot better than what you had, and you have a chance now of a statistically significant number of more PPM listening devices hearing those tones, and you getting credit for your listenership that you weren't getting before. That seems like nothing but a win-win-win to me. And again, I haven't heard anybody on the 25/7 staff pointing fingers at Nielsen saying your stuff is flawed. That's other pundits in the industry saying that. It works as well as you can make it work based upon the chosen tech. And I can't think of a better chosen tech in a one-way system like radio is to measure the people listening. I've yammered on enough. Bill Putney, do you have you're not in a PPM market there, are you?
We're not. I mean, we do cover parts of the Seattle-Tacoma market by accident, certainly not on purpose. But, I think this is an example of where the engineer has something to sell to the station management. If as an engineer you can understand the technology sufficiently to be able to optimize its implementation at your station. You know, if that's making HD work better, so that listeners can listen to it. If that's making the PPM counters peg on people's belts when they have your station tuned to it. I mean, that's something that you can go to the station. You know, stations always say, you know, engineers, they just cost us money. They buy tubes and stuff. You know, if we could only get rid of the engineers, you know, that would really be the optimal situation. Well, here's something: if an engineer, somebody that is willing to pick up, take the time, take the energy, pick up the information, most of which is out there, and say, you know, all these people are claiming all these things. What's true about all the things they're claiming, and how can I translate that into making this technology work in this station in a way that will make the station more money and make me more valuable? So, I mean, that there's, on the one hand, you know, we were talking right at the beginning of the show, you know, some engineers want to stand back from a new technology and kind of hands off it or you know, discount it so that they don't have to deal with it. But that's not the way to make yourself a viable part of the station operation. You really have to either research enough that you know what these things are and you know they'll be bad, and present your case to station management when the salesman comes calling with the best thing that's ever come down the pike, or recognize a good thing when you see it. Do your research, figure out how to implement it the best way you can, and make yourself a valuable asset to the station. Save the money when there's money to be saved. Make the money when there's money to be made. Engineers are problem solvers, you know, and those solutions have to make accounting sense too. I mean, I love to play with things, but playing with things very, you know, every once in a while it works out, but it doesn't make enough money usually to recompense the operation for my being there if I'm just playing with things. So, I mean, that's kind of my take on that. Like you say, we're not a PPM market, but I do read all the emails that come across I'm on a pub tech group, of course. So, you know, all those emails comes from all those smart people at NAB Labs and you know, all over the place. So I get this stuff, and it's a technical interest for me, but not something that is immediately applicable.
Good advice, Bill. And one thing I heard you say that I think was pretty critical, and that is be curious. Be curious. That's probably one of the most valuable things that an engineer can do for him or herself and his or her employer is to be curious. That's your job, is to look for better ways to do things. And as we've discussed here, not everything that comes down the pike or everything that a salesman has to sell is a better way to do things. And that's why we have to be curious and try. Go ahead.
It used to be that you know, every radio station you go. I'd love to go on the SBE tours in the summertime. We have a picnic out on Vashon Island, which is an island out in the middle of the Puget Sound, where all of the big AM stations, you know, from the 20s and 30s built their transmitters because it was a lot of open space that was like staring right down at the Seattle and Tacoma areas. But all these places had houses for an engineer to live in, and the FCC required that somebody be there because things, you know, tubes burn out and you know, anything was likely to happen. So somebody had to be there to go run across the parking lot, and plug in a new tube or switch to the standby transmitter. Well, that's not that way anymore. And, you know, we've had a Nautel transmitter going here, and I go out and I clean the air filters, but if somebody had to build me a house so I could be on call to clean air filters, I don't think that would fly. So in this age of more and more robustness of reliability of these systems, the engineer really can't sell his janitorial skills anymore. He's really got to be out there, in the technical trenches, helping management make these management decisions. And that's what all these disruptive technologies to come along, they're a threat and they're an opportunity. They're both things, and the engineer has to be there to make the knowledgeable, give the knowledgeable input to management about whether this thing is more a threat or more an opportunity. What's the likelihood that this is gonna drive us into bankruptcy or drive us to greater profits?
Good points. And I wish we all had a crystal ball to know those things, but sometimes we do get a gut feeling to see where the industry is going. Hey, our show, by the way, you're watching or listening to This Week in Radio Tech. We're about to wrap it up after this announcement from one of our sponsors, and so we'll have a quick wrap-up from Chris and Bill and myself in just a minute. We're talking about disruptive technology and engineers' reactions to it. When, how do you know when you should embrace it, when you should question it, and when you should maybe outright disregard it. And I don't think it's something you can decide very quickly. Our show is brought to you in part by the folks at Lavo, L-A-W-O, Lavo.com. They make this crystal clear console. Talk about disruptive. This is a console that doesn't have any knobs. It doesn't have any real faders. It's a touch screen. It's a multi-touch, in fact, 10-touch computer touchscreen. The console surface, if you will, is an app that's running on a PC that they've chosen that it'll run on, I guess any PC running Windows 8, but the one that they've chosen has a multi-touch touchscreen. It's a beautiful interface, and you can push faders up and down on the screen. You can push buttons on the screen, and then all the horsepower, the hard work of mixing audio and doing exactly what you tell it to is done by the DSP engine, the Crystal engine that sits in a rack, either near you or not near you. It doesn't have to be near you, but this is where the mics plug in and the analog audio and AES audio. It's also got a network jack because it does Ravenna, which means it also does AES 67. So if you want to be part of the AOIP world, the Lavo Crystal Clear console will do that for you as well. Dual power supplies are available. Of course, it has GPIO. It has all the things that you'd expect a console to have, like 2 program buses plus a telephone utility type of bus. Because it's a software-driven console, when you push a button on the console to select an option or do something, it's context sensitive. It's contextual. It knows, it knows to give you only the options that would be appropriate at that point. So you don't have to wade through long menus. The menus are clear and simple and only have to do with what you're wanting to do at that point. I encourage you to check it out on the web. There's a video on their webpage. Mike Dosh, the director of virtual radio projects at Lavo, gives an instruction, explains the console. It's just cool. If this kind of thing appeals to you, a virtual touchscreen console, yes, a bit disruptive, then check it out. Go to Lavo, L-A-W-O.com, look for the radio consoles, and then look for Crystal Clear. They have a series of consoles called Crystal. This is the Crystal Clear console that has the virtual interface on it. Thanks, Lavo, for sponsoring This Week in Radio Tech. All right, guys. Real quick, let's wrap it up with a final thought, if you will. Chris Tobin, what's your advice for folks approaching disruptive technology?
I would say do your homework. understand that at the end of the day, you have to find a way to generate profits, revenue, and as Bill pointed out, make yourself valuable in some form or shape other than just being a janitorial person. And yes, you could be considered an expense on a P&L sheet. However, if you find a way to generate the revenue and bring coins to the table, you no longer become an expense but a profit center, and that's something you want to work toward. And there's no reason why you can't do that with disruptive technology.
Bill, how about you? Final thought on disruption.
Well, I'd really like to have one of those Lavo consoles, but I got all these cans of pot cleaner. I am one of those. I'm a gearhead, I guess. Always have been. So I'm always interested in new things, but I think as anyone will tell you, as my wife will tell you, she says if a truck ran over me, that she wouldn't know how to run the house anymore. So I think as much as we as engineers would like to play with all the new toys, we also have to keep an eye on how usable are they for people when we're not around. So there's another aspect of that disruptive technology that if only we can understand it, that we have to be a little cautious about, throwing it ankle deep into the station architecture.
It's got to be good for everybody. It's got to maybe help satisfy our engineering curiosity. It's got to be good for the bottom line overall, and usable by the people who actually have to use it. Great points all around. Hey, we got to go. We've gone probably past our welcome here. Thanks to Andrew Zarian for producing This Week in Radio Tech at the GFQ studios in New York. Watch out for all the great podcasts on GFQ. Go to gfqnetwork.com and check them out. Also, thanks to Chris Tobin. Chris, you are reachable for consulting activities in the broadcast world at support@ipcodex.com. Is that right? Hello. Oh, there he is.
That is great. Sorry, I'm on the phone. Oh, this is disruptive technology. See? Look at that.
Oh, my goodness. What is that? Is that one of them Twitterbug, Shutterbug phones?
No, it's a Nextel phone, actually. It's i560. Yeah, look at that.
Maybe you got your AARP discount on that.
Yes, support at ipcodex.com will get you what your questions answered, hopefully. But
sorry to interrupt you. I know we've gone over time. All right, and obviously, Chris is a popular guy when it comes to supporting broadcasters and coming up with innovative ways to use IP technology to help them out. Bill Putney, thank you very much for joining us from Port Townsend, Washington. I appreciate it very much.
Well, I'm very happy to be here, and remember what Uncle Milty said: if opportunity doesn't knock, build a door.
Aha! That's right. That's right. Bill, I appreciate you taking time to be with us today. All right, we got to go. We'll catch you next week on This Week in Radio Tech. Bye-bye, everybody.